Hello, everyone. Good morning, good evening. I'm thrilled to be part of this event, and big thanks to Automation Guild for this opportunity. Now, let me ask you all a question. Have you ever clicked on something during a virtual event only to be stuck, waiting, and waiting? The stream buffers, pages, refuse to load, and suddenly what was supposed to be an exciting launch turns into a pure frustration. You are not alone. We have all been there. But what if I told you that with the right approach, we can predict and prevent those performance issues before they happen? I'm Dimpy, a staff quality architect at Vonage. And in this session, we are going to dive into smart workload modeling, an approach to ensuring application can handle real world traffic without breaking under pressure. Let's get started. So here's the quick agenda for today's session. We'll start with analyzing a performance test user journey. Then we'll do a concept deep dive, like what is workload model in performance testing. We'll understand it. Then I'll do some tooling intro for cases. And finally, we'll have a code walkthrough and demo. Imagine a product launch event, millions of users joining from all over the world. Some just tuning in, some maybe engaging in some activities, or others are just dropping off. The step one, the pre-event build-up session. A few 100,000 users may join early, excited for the teasers. Then when the actual event starts, like suddenly you can see traffic spikes from 500K to over 5 million within minutes. Then the feature highlights where they will, share their key features. The users fluctuate as they engage, and few may exit. And finally, the grand reveal of a flagship product. This is the peak. You can see 10 million plus users flood in. And finally, the post-reveal Q&A session. Traffic drops gradually as user moves on. Now, why is this important for us, right? Because if we don't model this workload correctly, we risk failures where and when it matters most. So, what are the key considerations we can get from this performance user journey analysis? Number of concurrent users, user arrival patterns, the transaction mix, ramp up and ramp down, and duration of transaction, and finally the various load patterns. So let's now define workload in performance test in a formal way. You can think of a performance model as a flight simulation for your application. Before an airline lets a pilot fly, right, a real plane, they train in simulations with different weather conditions, engine failures, and emergencies. Similarly, we build workload models to test how a system behave under different traffic conditions before they go live. There are various types of workload models. Let's understand those. First one is real-world trace workload, where we use production data for realistic scenarios. This is applicable when you already have your application in production and you have some data to refer, and you have also analytics, dashboards available for analyzing those patterns. Another way is using some mathematical models and formulas. Using those formulas, we can simulate the potential user behavior. Third option is simulated workload. This is like creating an artificial traffic for a new system or or features based on business SLAs. Each of these has its place, but the key is choosing the right model for your scenario. Next is why user arrival patterns matter for us. If you see in this diagram, the traffic never goes flat, right? So you can see sudden spikes. Users don't trickle in slowly, right? So they may rush in all at once. You can also consider think and pace time because real users pause between actions, unlike automated test scripts or bots. And time of a day pattern, right? So because traffic changes based on the events, holidays, or like global time zones, etc. Next is applying queuing theory. Little slow, yeah, it's little fun here because this is a mathematical model or formula where L equal to the average number of users in a system, then lambda is arrival rate, like how fast users are entering into your system, and W is the time spent in the system. Uh, in performance modeling, we add few additional things so that our formula is more relevant to us. So little law can help us to estimate how many users can be handled by a system at any given time. And we incorporate think time and pacing in user load calculation. So we user load equal to like transactions per second divided by number of requests and multiplied by sum of like overall response time, total think time, and pacing. So if I need to combine all this together in an example, this will look like this. So suppose you have 100 transactions per second, and then each user makes 5 API calls. The response time equal to 2 seconds per request. Think time is 5 seconds. Pacing is 10 seconds. Then the calculated load will be around 340 concurrent users. So next is tooling, because till now I have covered only the concept part. So for this presentation, I'm considering K6. So why K6? Again, this is an open source and cost-effective tool. It is very scalable. We can simulate any number of loads and provide real-time actionable insights. So there are some installation dependencies. Like, yeah, it supports multi-platform, Windows, Mac, Linux. Docker image is also available. Then we can use Node.js for script management. So with K6, we can define test parameters, we can control the ramp up, ramp down, and we can also simulate real world think time and pacing. Yeah, it has a lot of many other features, but these are some of the important things. K6, we have executors. Executors control how K6 schedules virtual users and iterations. Executors that you choose depends on the goal of your test and the type of traffic you want to model. We can actually model both like open as well as closed workload. Like K6 has a lot of options in both the sides. For example, like K6 supports constant views for closed workload, like a fixed number of virtual users execute as many iterations as possible for a specified amount of time. Then we can have constant arrival rates, which is an open model, a fixed number of iterations executed in a specified period of time. And we have ramping views or ramping arrival rates, as well as we have shared iterations and per view iterations. We will see all these things in our demo section. So let's jump into the demo now. As we have seen in the previous slides, K6 provide different executors. So in this demo section, we will see each of those executors, and we will also understand how we can use different executors for different scenarios we have. So first one is constant views. So in constant views, the number of virtual users will be fixed for a specific duration. The number of iterations we will not be able to control in this case. As many iterations is possible for this particular use case will be executed. And in the default function, I'm making a get call to a K6 demo endpoint. So I'm running the test. So it is executing so many iterations. It's completed, and you can see within 30 seconds we are able to complete 559 iterations. So if I go to the report now, 5 virtual users, and in the summary section you can see the rates, like we got like 18.48 per second throughput with 5 virtual users. So this is the simplest executor in K6, which can be used to model close workload. Next, let's see the constant arrival rate. So in this case, I'm keeping the duration same, but I have added pre-allocated virtual users as 20, and I have controlled the rate. So I have specified 5 requests per second, and I'm making call to the same endpoint. So in this case, you'll be seeing like the number of virtual users are more. We're also got some warning like insufficient virtual users, reaching 30 active virtual users and cannot initialize more. Let's see how many iterations it is able to complete. Okay, so you can see here this time we are able to complete only 99 iterations. That is because we have restricted the rate. And if I go to the report, you can see this is the previous report, and this is the RAM constant arrival rate report. You can see the virtual users gradually increased, as well as if I see the rate section, you can see decrease in the rate. So this is another executor provided by K6. So next, see the ramping ones. We have two in the ramping section. One is like ramping views, and one is ramping arrival rate. So in the ramping views, we provide stages, and we provide for each stages, we can provide the duration and the target. For example, like for first 10 seconds, we want 5. Next 10 seconds, we want to maintain 5, and next 10 seconds, we want to ramp down. So this is how we represent it. And in the ramping arrival rate, we can it is similar, but in this case we can control the arrival rate. We can specify for a particular time how many requests we are expecting, what is the rate basically. So let me run both and show you the differences. I'm running the ramping views. You can see it is getting executed in stages, and for each stage the iteration count is increasing. Okay, total 413 iterations got completed. If I go to the report, you can see the rate is now 13.66 per second. And if you go to the virtual users, you can see the ramping pattern here. So let's go to the next and execute the ramping arrival rate. Again, we are getting some warnings like, it reached 50 active virtual user state and it is not able to initiate more. Let's see how many it got executed this time. You can see it's much higher than the previous one. And if I go to the report, this is the previous report. You can see the pattern of how virtual users are getting created, as well as you can see a very higher rate. So this is basically suitable for like spike tests or stress tests. Next is shared iteration. So in case we want to share the iterations among the virtual users, we can use shared iteration. We can specify the duration, iteration count, and virtual user count. And if you want like fixed number of iteration for each virtual user, then you can use par view iteration executor, where like, give the iteration count and virtual users and max duration. So let me run the shared iterations executor first. Now you can see for all the 5 virtual users, iterations will get shared and it is increasing. And let's see how many iterations it is able to complete within 30 seconds. Again, there is no guarantee that all the iterations will get completed, but K6 will try to execute as many iterations as it can. So we can see, wow, so it completed 600 iterations. And we'll see, go to the report. Yeah, we can see rates has come down and the count is 600 this time. So let me run the par view executor as well. Yeah, again it is executing. Let's see how many it is able to execute this time. So you could see like 607 iterations it could execute total. And if I go to the reports, you can see slight increase in the rate as well as the count. All these different types of executors help us to create dynamic scenarios as per the requirements. As I have showed you in the slides, the sample user journey. Let's see a simulation of that user journey. You can use multiple executors in a single file under the scenarios. For example, in this case, the first executor is ramping arrival rate with rate control and stages. The second scenario is event start scenario with ramping arrival rate, but we are specifying different values, durations, targets, and all. The third one is feature highlight, which may need constant arrival rate. Here also, no, I have specified like timeout, duration, and the rate. Followed by the grand reveal stage, again ramping arrival rate, and finally, post reveal QA stage, we are using ramping arrival rate for different duration and time. We have added a threshold as well, and also one important thing, like we are considering the think time and pacing time here. So after each request, we are adding think time, and finally, before starting the next iteration, we are adding a pacing time. So in this way, we can actually simulate the real world scenarios in the performance test script so that we get more accurate results. Okay, so we are done with the demo. So, what are the key takeaways and call to action from this presentation? So, workload modeling ensures that we simulate real user behavior, not just artificial this data. Real users don't arrive in a straight line. Traffic is unpredictable, and we should consider that fact while designing our test. Applying formulas like queuing theory helps us, estimate system limits. And finally, tools like K6 can help us to execute smarter and more reliable load tests. Ultimately, great performance testing isn't about, how many users we can handle. It's about ensuring an amazing user experience for the clients. Thank you for your time. I'd love to hear your thoughts and questions and experience with performance testing right after this presentation in the Q&A section. Thank you.